Right, so hello everyone and welcome to McLearn 360. So in this video I want to solve this question with you. Sorry. So this question is actually about vibration of a connecting rod which is behaving like a compound pendulum. Okay, let's go ahead and solve the question. So we've got a connecting rod which is having a mass of what, 40 kg, and then it is suspended vertically as a compound pendulum. Now the distance between the bearing centers, so when this is what we call the bearing centers, whenever you take a connecting rod, you will have this small end diameter and then you have this big end diameter. Okay, so let's call this side S, which is the small, and B, which is the big. Okay, now interestingly, for the same time of 60 oscillation, for a frequency of 60 oscillation, the time was found to be about 92.5 when the axis of oscillation coincide with the small end. So essentially what this means is that, you know, the period at the small end is what? So number of oscillation divided by time. The time taken divided by the number of oscillation, because we know that 1 second is actually the time taken to complete an oscillation. So if you have 60 oscillation, then it means that 60 will be more, and that is the reason why we are dividing. So 92 divided by 60, that's what I want to say. Okay, and actually if you do this, it's going to give you what? So let's calculate the period for the small. Okay, so you are going to get 92.5, and then you divide it by what? 60, and that's what. So basically that's going to give you 1.5417. So 1.5417 second. Essentially you calculate the period for the bigger one, but you realize that he said that it was coinciding with the bigger period, and that one, it was what? So the small end center, and then what? 88.4 second when it coincides with what? With the big end center. So essentially the big end center will take 88.4 second, and then you want to divide it per the 60 oscillation so that you get the period for each oscillation. That's essentially what you want to do. And if you divide 88 by 60, so that's going to give you, so you will get 88.4 divided by what? 60, and that's essentially going to be 1.4733. okay, so let's say 1.4733 second. Now these two periods that you have gotten is what we are going to use in the calculation. Okay, now pay attention here. Whenever you have all right, so whenever you have a compound pendulum, the period of a compound pendulum, people, is given by 2 pi square root of I naught divided by mjh. So where I naught is what we called ij plus mh squared. Okay, so essentially what we have here is that whenever you want to find the period of a compound pendulum, it is actually given by the 2 pi, which is a constant, multiplied by the square root of what? The I naught is the mass moment of inertia about the center of gravity. So or let's say the total mass moment of inertia, let me put that way. So the total mass moment of inertia is given by Ij, which is the mass moment of inertia about the center of gravity, and then plus what we call the parallel axis theorem. So this is actually the parallel axis theorem. I know you are familiar with parallel axis theorem from your dynamics class, so I will not really go over that. But then the whole idea is that this formula is going to help you to calculate. Okay, so now the whole idea is that we don't know where the center of gravity is about the big axis or the small center. But then if you look at the question carefully, the question said we should actually calculate the distance of the center of gravity from the small end center. Okay, so that's what the question was calculating, have asked us to calculate. So what we can do is that we can essentially start off by assuming that, okay, so we don't know, but let's assume that there is a distance here. Okay, let's say there's a distance here to the big one. Let's call that, say, x. Okay, so if this is x, then we can say that, you know, this is going to be what, if the whole length is if the whole length if the whole length is 800 millimeters or 8 okay, so let me write it well. So 0.8 meters, right? So essentially this length is going to be L minus what, X, because this whole length here, it represents what, the whole 0.8 represent the L. Okay, in other words, we can say that if this one will be X, this one will be 0.8x. Okay, anyways, so people, let's get started. So essentially we are just going to play around the formulas. The period is going to be, so the period is going to be 2 pi multiplied by, then you start. So Ig is the center of gravity, the mass moment of inertia about the center of gravity plus the mass, which we know, and then we multiply by h squared and then divided by mgh. Okay, so yeah, so this is the formula. We are doing this because whenever you have a compound pendulum will behave like something like this. So all the time a compound pendulum will be like something like this, and then there will be a certain weight here. The weight will be acting vertically downwards. Okay, and so there will be a point of attachment here. So that h is that distance, which is what, all the time you see that distance from the center of gravity. So essentially that is the h that we are talking about here. So, but then in the purpose of analysis, we are going to assume that we'll be dealing with the big and the small center. Okay, all right. So for the small center, we are going to use the period of the small. Okay, so if we use the period of the small, then essentially what we are going to do is that we will do, so 2 pi into, we don't know Ig, plus the mass. So the mass here, okay, so all right, so I think we have to change something here. Sorry for that. So the small one is actually x, because that's what we are actually asked. They have been asking us to find, and the big one will be L minus x. Sorry for that. So essentially for the, okay, so this is the formula anyway. So for the TS, we are going to use the small period. Okay, so everything here will be for the small one. So it's going to be what, Ig plus what, plus m. And for the small one, the center of gravity, the distance will be what, x squared, all divided by what, mgx. That is to say, if I use the small one, okay, please take notice of this. This x here is the distance from the center of gravity to the small center. Okay, so this is small center, the bearing, the small center, and then the b here is the big center. Okay, so please take notice of that. And then essentially what this means is that if we want the big center, the period is going to be straightforward, the same thing. Okay, but then this time around it's going to be the other way around. Okay, so it's going to be, so the square root of Ig plus m, but this time around you see that the distance from the center of gravity to the big center is what, L minus x. So we will rather use the L minus x, okay, for the big one. So L minus x, but we know L is 0.8. So 0.8 minus x all squared, and then divided by what, mg. This time to the distance will be what, 0.8 minus x. So you see that it's very simple, but the whole idea is that we can assume that the x is the distance from the center of gravity to the small one, and then the L minus x will be what, for the big one. Let me just even write 0.8 minus x, because we know L is what, 0.8. Okay, so that is the problem. In fact, I have finished solving the question. The rest is algebra. So what do we know? We know that tx divided by 2 pi will be equal to what, square root of what, Ig plus m s squared, all divided by what, mgs. Okay, so squaring both sides, ts divided by 2 pi all squared is going to be what, Ig plus what, m x squared. So if you square both sides, it will take the square root away, and then I have mgx, right? And then essentially when I come here, this one will be what, TB over 2 pi, then I'll square both sides again, then it will take the root away, okay, and then I have what? So yes, I have plus m 0.8 minus x squared divided by mj multiplied by 0.8 minus x. So that is it, right? But then what do we know? Of course, everybody knows that. So let's calculate this. First of all, let's calculate the period. What do we know? TS is giving us what? So TS is giving us this one, the small period, 1.5417. So it's going to be 1.5417 divided by 2 pi. Then we square this, right? And this should be equal to Ig. That one we don't know. In fact, that's what we've been asked to find. The mass was 40, and then we are multiplying by what? X squared. And then we divide this by what? The mass, which is 40. Everybody knows that J is what? 9.81 multiplied by X, okay? So essentially, that is it, right? And then if you come to this aspect, you see that the same thing, but then this time around, you are going to use the big period, okay? And that is what? 1.4733. So 1.4733 divided by what? 2 pi, and then squared. Should be equal to what? Should be equal to Ij, okay, plus 40 multiplied by 0.8 minus x all squared, all divided by, so all divided by 40 multiplied by 9.81 multiplied by 0.8 minus x. So you see that up to this point, we are done with the basic, we are done with the mechanical vibration, okay? At this point, it is only left with what? Algebra. So I can even end the video here, and then you do the algebra. But because I want to solve it with you, let's do the algebra together, okay? But at this point, if you have been able to set up these equations, you are almost halfway through. Don't forget that we have equation 1 and we have equation 2. Equation 2 unknown, so you should be able to solve. At the end of the day, you are solving for Ig, and then you are solving for x. And that is the question, all about what the question is asking you. How easy the question is, okay? So let's do everything together, starting from the first equation, okay? So from equation 1, what can we say? We can say that if we calculate this one, so 1.5417, and then we divide it by what? 2 pi, okay? So if we do this, we get what? So essentially the square of this one, okay? And what is that going to give us? Okay, so the square, sorry. All right, so if you do the if you do this and square this, you get 0.0602. So 0.0602 will be equal to everything which is here, okay? So it's going to be Ig plus what? 40x squared. Then you divide this whole Ig plus 40x squared by, so if you multiply 40, so 40 multiplied by 9.81, okay? And that's going to give us what? 3. So that gives us 392.4, right? So we have 392.4, isn't it? So 392.4. So let's make Ig the subject, okay? Or let's try to, so Ig plus 40x squared will be equal to what? Let's do it straight away. 0.062 multiplied by 392.4, okay? And what is it? So if we do this, we have 24 point, sorry, it's 0.0602. Yeah, 0.0602. So it's going to be 23.62, right? Or let's say it's 23.622. So 23.622 let's call this still equation 1. So we need to also come here and do the same thing. Okay, so I hope now you are getting the picture of how the answer is going to be, because at the end of the day we are just going to solve simultaneous equation. We are done with the vibration, so forget about the vibration for now. We are just doing simultaneous equation. So 1.4733 divided by 2 pi. Okay, now if you do this and then you square this, you have 0.05, let's say 0.05. Okay, 0.05 5, so 0.055, right? So 0.055, and then this is equal to Ig plus so now I want to open up this one quickly. So if you want, so if you have 0.8 minus x squared, it's going to be simple. Okay, all what you have to do is the square of this one, which is 0.8 squared, minus twice the product, which is 2 times 0.8x, and then the square of this one. So okay, maybe let me bring it down, don't worry, let me bring it down. So it's going to be 0.0550 should be equal to Ig plus, so 40 into, so the square of this minus twice the product. Okay, and then after doing that, essentially you've got right, okay, twice the product, yeah, and then plus the square of this. Okay, now you divide the whole of this by 40 into 9.8 into 0.8 minus x. So you see that this one is also simple. All what you are doing here is just basic algebra. Okay, so I can even decide to end the video, and I hope you can even continue, but it's fine, let's do it together. Okay, so now this is it. Okay, so I have Ig plus 40, so let's do it together. 40 multiplied by 0.8 squared, so 40. Okay, so 40 multiplied by 0.8 squared, you have what? 25.6, isn't it? So 25.6, and then you have 40, so you have 40 multiplied by 2 multiplied by 0.8, and what is that? That's 64, right? So minus 64x, and then plus what? 40x squared. Again, you do the same thing here. So you pick your calculator, so 40 into 9.81 into 0.8. Okay, and that's what? 313.92. 313.92, right? And then you do the same thing. So but then this one, 40 times 9.81, then you multiply by the x, so 40, and then you multiply it by what? The 9.81. Okay, so 40 multiplied by 9.81, right? Okay, so you get 392.4. Okay, so you have 392.4x. Okay, 392.4x, right? So it's your task to now multiply this, so 0.0550 all into 313.92 minus 392.4x, isn't it? And then you equate this to Ig plus 25.6 minus 64x plus 40x squared. Okay, Okay, so ig plus 25.6 minus 64x plus 40x squared. So if we do change of subjects, so we have 0.0550, which is multiplied by 313.92, and that gives us 17.265, or let's say 17.266. So 17.266 minus again 0.0550 multiplied by 392.4, and that's what, 21.582. So 21.582x, right, should be equal to what? Ig. So you see that still we are dealing with Ig, and then what? X. 64x plus what? 40x squared. Now, so yeah. So at this juncture, all what we have to do is to just find some way to sort of rearrange everything here. So we can say that Ig from here, Ig will be equal to what? If we send the 64 to come here, you see that this 40 here is negative. So it will be minus 40x squared, okay, plus, and then if we do minus 21.582x, and then plus 64x, so we have 42.418, so plus 42, so plus 42.418x, okay, that is it. Sorry, that is it. And then you've got minus what? So again, let's do this one. So you have 17.266, and then minus 25.6. Right. So if you do this, you'll get minus 8.334. So 8.334. Right. So in fact, at this point, I cannot continue again. Why? Because I think this is too simple for you to solve it. So you have this equation 1 here, okay, and then you have this equation 2 here, okay. So please use equation 1 and equation 2. Interestingly, there is 40s squared, and then there is what? Minus 40s squared. So it's okay, let me do it for you. In fact, if you do it correct, the Ig will be equal to 2.61 kilogram meter squared, and x will be, I don't know. I know it, but please solve for s and put it in the comment section. Thank you very much. Just solve the two equations simultaneously. You should be able to do it. In other words, pick this Ig, okay, and come and put it here and use it to solve for x. Then you can solve the other. Right. Thank you very much for watching.